Aim 27. How do we simplify radical expressions using multiplication and division? For tonight's homework, all we're doing is practicing what we did in class today, which is simplifying radical expressions using multiplication and division. What I like to do first is recall the product property of radicals and the quotient property of radicals. Okay, so as we remember, whenever we have radical a, b, it's also equivalent to radical a, radical b. Now I'm going to show you how we can use the same property with actual numbers. So let's say I have radical 18. Looking at radical 18, I know that that is not a perfect square. So I'm going to try to find two factors which one has the largest perfect square. In this case, I know that I'm going to use 2 and 9. So I put radical 9 and radical 2. Radical 9 and radical 2, when we multiply them together, we get radical 18. However, to simplify it, we'd have the square root of 9, which is 3. We can't do anything else with our radical 2, so we'll leave it as that. So radical 18 is also equivalent to 3 radical 2. Okay, so now let's review the quotient property for radicals. Essentially, we're doing the same thing. So we're going to start off with radical a over b. And just as we did with the first one, with the product property of radicals, we're going to take the square root of each term. So we're going to have radical a over radical b. We're essentially squaring or finding the square root of each, the numerator and the denominator. So now let's do an example with actual numbers. If I have radical 49 over 36, in this case all we're doing is getting the square root of 49 and the square root of 36. In this case, they're actually both perfect squares, so then our ending result is going to be 7 over 6. So that's how we use the product property of radicals and the quotient property of radicals. For homework, you all were assigned page 485, numbers 21 through 24, and then some other numbers 47, 48, 83, and 84. The example that I want to go over with you guys is actually number 25, where we have radical a to the third power over 49. Looking at this, I know that I'm going to be using my quotient property. So, in order for me to break it down, I'm going to break it down by having a to the third as my numerator, the square root of a to the third, and then the square root of 49. In this case, we have a variable raised to a power. So, being that we have that, we know that we're going to have to use our exponential rule. We know that whenever we're multiplying exponential rules, we're actually just adding our exponents together. So, in order to break it down, I'm going to have a squared, radical a squared, and radical a. The reason why we get a squared, radical a squared, and radical a is because when we multiply a squared with a, we are going to get a to the third. And for now, I'm just going to keep our denominator as radical 49 because I want to work on my numerator first. So now, back to the numerator. We have the square root of a squared and the square root of a. Looking at these two, we know that radical a squared is actually a perfect square, so we know that we can get the square root of it. We get the square root of an exponent by dividing the exponential value by 2. In this case, when we divide a squared by 2, we're going to get a to the first. So that leaves us with a, radical a, And now I'm going to move on to my denominator. The denominator is asking us for the square root of 49. Being that 49 is actually a perfect square, I'm just going to simplify it to 7. So our answer for number 25 would be a, radical a, divided by 7. Now I'd like to move on to number 47. This is actually an assignment from your homework. Number 47 is asking us for radical 5 divided by radical 48. They're asking us to simplify this expression. Here, when we look at our numerator, we see that we have radical 5. Being that 5 is a prime number, we know that there's nothing else that we can do with radical 5, so we're going to leave it as such for now. So we're going to have radical 5 in our numerator, and we're going to keep it that way. Now we're going to look at the denominator. We have radical 48. Since 48 is not a perfect square, I'm going to look for factors of 48 where I can find the largest perfect square. So on the side here, I'm going to write 48, and then I'm going to write all the possible factors for 48. Based on the factors of 48, we have 1 and 48, 2 and 24, 3 and 16, 4, 12, and 6 and 8. I'm going to look for the pair which contains a perfect square and contains the largest perfect square. So, here we have 3 and 16, and then we also have 4 and 12. Now with 3 and 16, we know that 16 is going to be our perfect square. And in 4 and 12, we know that 4 is also a perfect square. The way we decide which one we're going to use is by judging which one has the largest perfect square. In this case, we're going to use 3 and 16. So now I'm going to write my factors as such. I'm going to write radical 16 and radical 3. I'm going to bring it down. And now, I know that 16 is a perfect square, so I'm just going to get the square root of that, and I'm going to get 4. 3 is a prime number, so I can't get a square root of 3, so now I'm going to just write radical 3. So now I have 4 radical 3 in my denominator. However, we know that we can't have a radical inside of our denominator, so the next step that we'll take is to multiply our radical 3 by our denominator and our numerator. So here, I'm going to write it here. When I multiply two radicals together, we know that we're going to get radical 15. And then when I multiply 4 by radical 3 by radical 3, we're going to get 4 times radical 9. We know that 9 is a perfect square, so then again, we're going to have radical 15 divided by 4 times 3. And our final answer should give us radical 15 divided by 12. And that is our final answer for number 47.